I'm back, and now we're going to do part 3 of the lab, which is entitled the ramp. And so here is a picture of a ramp. So the concept of a ramp is you've got this box, and the goal is to get the box up here. Now there's two different ways of doing it. You could lift the box straight up. So you could grab the box, lift it straight up into the air. So that would mean that you have to lift the full weight. So this is going to be the weight of the box, and then this is going to be the distance that you would have to lift it. So that would be, you wouldn't want to do that. So lifting that box straight up into the air would take a lot of effort in order to do that, because you're lifting the full weight of the box. So in this diagram here, that's going to be force out. So force out is going to be the weight of the box. The other way of getting the box up to here is to start with the box over here and then to push it up the ramp to the same position. So notice that this box ends up at the same height that this box did. But the difference is you're applying the force over here, and then here is the distance that you're moving it. So you can either move with a force on this box this distance, or this force on the box this distance. So again, we've got two forces and we've got two distances. Force in, distance in, and then force out, and then distance out. Now the distance that's going in is going to be the length of the ramp. The distance that's coming out is going to be the height that you're going to lift it to. And so in geometry we call that the rise, but it's the height that you're lifting the box to. But it's the same formula. So this formula up here, and we're going to use that in order to do it. So we're going to open this simulation here. So when you open it, you're going to find this thing. So here's our ramp, and the goal is to get the box into the back of that pickup truck or whatever. So it says to set the friction to 0. So we want all of the energy going into the ramp to be all the energy coming out of the ramp. We don't want to consider friction. So if we go back to here, you have this slider here, and if you take this slider and you move it back, it now has 0 friction on it. Now after you've done the simulation, you can turn up the friction just to see what the difference is going to be. But we're going to keep it simple to start off with 0 friction on that. Given the load, the ramp length, and the ramp height, calculate how much force should be needed in order to push the box up the ramp. Okay, so you can get what the load is, you can get the length of the ramp, and you can also get how high that you're lifting it off the simulation. So all of that, here's the load, so that's what you're lifting. So that's this thing over here. You have the length of the ramp that is given to you, and you have the height of the ramp. So that's given. So these are the 3 pieces of information that you got. So now take those 3 pieces of information, plug them into this formula here, and figure out how much force should you need to push with in order to get this thing up the ramp. So you're going to know the length of the ramp, you're going to know the height or the rise of it. You're going to know what the weight of it is. So that's going to be the force that is coming out. And then the goal is to figure out what amount of force do you need to push with in order to get it in there. So I'll let you do that. And you're going to be filling in this chart. Now we're doing column number 1 with no friction. Measured rise of the ramp, measured load, measured length of the ramp, and then calculate the amount of force that it should take in order to push it up the ramp. So you're going to put that right there. Okay, then the next thing is to actually do the experiment. So once you have figured that out, then what you can do is you grab this thing and you start pulling on it. So I'm going to pull with a force of, what is that, 0.38? Nothing's happening because I'm not applying enough force yet. So you just keep applying force to this thing until it finally starts to slide and it'll go into the bed of the pickup truck. And then I want you to, whatever it says was the force, then you're going to put that right here under measured force it took to get it up into the pickup truck. Okay, then I want you to calculate the amount of work that came out and then the amount of work that went in. So the amount of work that comes out of the machine is going to be labeled potential energy. And then the calculated work that goes in is going to be labeled work done by the machine. So if I go back to here, now let me just go ahead and do it. So I'm just going to keep, no, I'm going to keep, no, I'm going to keep, oh, there it goes. Okay, and then you see over here, so it's got the applied force, it's got the work done. Now we didn't talk about mechanical advantage, so don't worry about that, but do look at down here under efficiency. And so look at these two numbers and look at this efficiency, and then you should know that this is 100%. So it's a 100% efficient machine because there was how much friction? 0. Now I want you to redo it. So hit the reset button and redo your calculations, but now you're going to have 0.5 friction. And this time it's going to take more force in order to get it up the ramp, and it's going to take more energy to get it up the ramp because there's going to be friction involved. Okay, so now we're ready for part 4, which is the pulley. And I'll see you in just a moment.